worse. Because if you notice, if I hold still enough, you can see fumes coming off of it, right?
Yeah. Isn't that the stuff that's in your stomach?
God. The fumes off of hydrochloric acid are actually quite a bit stronger than the fumes in ammonia.
Does it smell?
Yeah.
Okay, so we can check odor.
I'm not getting any on my skin. If I did, yes, it would be no good.
Like, it was like, what do we name it?
Yeah, what do we name?
Okay, here, yeah. Let's add that. This is hydrochloric acid, which is HCl plus Zn. Zn is zinc. Zinc is a metal right off of the periodic table.
Wait, you zinc.
Yep.
How many more do we have? Is that
Oh, you can just stick it in your mouth.
Okay. Zinc is not toxic. I do not recommend you put it in your mouth. I'm going to pass one piece around the room.
Isn't it good for you?
Okay. Zinc is actually an essential vitamin and mineral. Yep. It can be found in most children's cereals.
If it's in like stuff like that, why is it? I love Chucky Lawrence.
I love Chucky. Lucky Charms.
I love Chucky Lawrence. If he says
You hate it, then why would it be?
All right. 5,
yeah, Blaine would
4,
have it.
3, 2, 1. Okay, now I'm going to take the zinc and I'm going to put pieces of it inside of a balloon. Now, the balloon is simply going to hold these so that I don't drop them in directly into the acid. And then the balloon, is going to capture one of the byproducts of the reaction. Good guess.
How'd you get it?
Alright, that's pretty good. Okay. Pop the balloon over the top here.
It popped. I'm gonna scream as well.
Alright, here we go. You ready?
Here we go. Oh, this is when it explodes.
Is there a
There we go.
Is it gonna explode, Mr. Webb?
No. Now, the gas that's produced out of this, there's quite a bit that's being formed, but it won't be enough to pop the balloon.
Oh my gosh, guys, look.
Now, zinc, those of you that have seen it, it is coming around. It's at the back right now. It is gray in color, and if you look down at the bottom, the zinc is now what color?
Black.
If you can see it, it's black. So we're definitely seeing a color change.
Look at the one spike of
And we're also definitely seeing a gas.
What about temp?
Odor.
And temperature, yes, this is hot enough that it's extremely uncomfortable to touch.
Yeah. Did he odor?
So would there be an air or
Would it be an odor change?
Alright, now, the odor, because hydrochloric acid has an incredibly awful just odor. And once this is done, the odor's gone. So could that be odor change?
Yes.
Yeah.
Is that why you're? Is that like when you throw up? It smells so bad.
Well, and Coach Smith actually pointed this out. She's our resident biologist. She knows more about biology than most of the rest of us. The acid in your stomach is actually pretty close to as powerful as this. And so that's part of the real problem with the odor in vomit, though, has more to do with bile than it does with acid. Now, here's something about acid as this begins to calm down, just to mention. Acid in real life does not work the way it does in the movies. In the movies, they have acid like coming out of the mouth of aliens, and it melts right through metal. Then you have shows like Breaking Bad, and they get rid of evidence by boiling it away in acid, that kind of stuff. It just doesn't work like that. Acid like this, and this is about as powerful as you can get on a common market without needing some sort of special license. It would take several hours just to remove the first several layers of my skin. Okay? So it's not going to like dissolve my hand or anything crazy like that. However, it can create a chemical burn, and chemical burns are very, very irritating. The burning sensation doesn't go away until it's practically healed, and it looks like a really bad rash, and it won't go away. Okay? Yes?
So if you swallowed some zinc, like a piece like that, would that same reaction happen in your stomach?
No. Well,
I mean,
because I don't think the acid in your stomach is hydrochloric acid, but I would need to look it up. If I could get more gas in it, it would float. Hydrogen gas is lighter than air, but I don't have enough in it to actually make it float. And you'll notice that the balloon does appear to have shrunk, and that's not because I'm losing gas. That's because this reaction is very, very hot, and the test tube at the top is not cool enough that I can touch it, but at the bottom, it's still very, very warm. Gas, when it's hot, likes to do what? Expand. And when I take it away from its heat source, it begins to contract because it's cooling down.
What does it smell like? I think I'm smelling something.
It smells like yellow.
Does it smell like?
You're smelling hot balloon is what you're smelling. Okay. Let's clear a few of these. I'm clearing mine. You just add to yours. You don't need to erase anything. Okay.
Casey Cooper.
Add on
My
to
favorite song.
Just add on to the bottom of it because that line is very hard to add that in.
That's my show.
Alright, the next one we're going to do is, hey, right over here. The next one we're doing is hydrogen gas plus oxygen gas in the air plus heat added from an outside source. So I need a victim.
I deserve this. How many times you scared me? I didn't go to your
Mr. Wagner, do it to Audrey. Do it to Audrey.
You know, the first one we did was a guy. Everyone else has been a girl, so we need to do a guy.
Alright, Drew. Yes.
Nice going, Drew.
I really called him.
Alright, zinc. Zinc piece. Thank you. What?
So,
Am I gonna what?
we didn't see.
Oh, you didn't?
No, toss this.
What's in the bucket now?
Well, just toss the bucket.
Zinc.
All it is
All it is metal. Touch the hole underneath your chair.
If we've got time, I'll pull it back out.
No, it feels way different.
Okay. I'm about to give Drew some very important instructions. Listen, he needs to hear them all. Hush. Okay, Drew, first, wear this. Okay, second. This is a highly technical piece of scientific equipment called a match on a stick. Treat it with respect, because if you don't, it will hurt you. Okay. You're going to hold this match on a stick at arm's length. Okay? You want to be back away from it. Okay? You don't want to be on that end. I'm going to light it with that lighter. When I light it, you're going to stand still and you're going to let me exit the vicinity. And then when when it's burning, you're going to actually lower it down here next to the balloon, and your goal is to catch the balloon on fire. Everyone in this area needs to move.
Behind me. Behind me. Behind me.
Pretty excited for this, not right here.
Basically. Alright, now you did sign the waiver at the beginning of the year, right? Okay.
Pretty sure.
Oh, someone hit the lights for me. Alright, here we go.
Where's my phone?
True. Am I good? Catch it on fire.
Go, go.
Wow.
What the heck?
True, you're magical.
Good job.
Oh, that's horrible.
Don't touch the balloon.
Yeah, you can set the balloon right over there. That's why I had y'all move, because the balloon was likely going to move. Okay, this, ladies and gentlemen,
I wonder why.
listen. Hey. This, ladies and gentlemen, is the hydrogen gas. That was what was in the balloon, bonding with oxygen in the air. What do you think is created when hydrogen and oxygen bond? Water. Water. The byproduct of this was water. With flame, obviously. We did have a flame. Yeah, and there's actually water on the
That's why
table.
the
Water
balloon
droplets.
was wet.
That's why the balloon was wet. The heat and the flame from the match actually started the reaction, and the reaction happens extremely quickly. The reaction happens so fast, in fact, that if we had a container, say, as large as the building of Heritage, filled with hydrogen, like this blimp.
The Hindenburg.
This is the Hindenburg back in 1937. It was the largest blimp in the world at the time. And like I said, the Hindenburg's balloon was about as big as the Heritage building. It is using hydrogen gas to float because hydrogen is lighter than air. And on the bottom, you can't really see it, there's a box that's about the size of this room with about 30 people in it. When it came into land in New York on its final flight, something happened. We're not entirely sure, but we do have some guesses what happened, but it ignited. The hydrogen gas inside is so volatile that it takes something, this is real-time video, this is not fast-forwarded at all, it takes a blimp bigger than this building and burns the entire thing to nothing in less than 20 seconds. There were 30 people on board. None of them survived. Well, the 30 might actually be a little low. I think there were 35, 36, something like that. But anyway, so 30 seconds and that whole thing's gone. Now, one of the popular theories about why it actually burned was because the casing on the outside of it was actually coated in aluminum-based paint. Aluminum, when you combine it with iron rust, creates something called thermite. Thermite is extremely reactive. It can go off for almost nothing. And when that thermite ignited, it burns hotter than the surface of the sun, lit the hydrogen gas inside of the blimp, and then everything just went to heck from there. Okay, so hydrogen gas, very, very volatile. Now, let's go back to our checklist. With this reaction, what did we see?
Gas.
Definitely got some gas.
Temperature.
Temperature, light, flame. Not really any color or odor though, right? The odor here was just because the balloon got hot. All right, thank you, sir.